We're going to start with some very basic limit problems. And the most basic limit problems, we always try just substituting the value for x. The value that we're approaching, we substitute that in for x. If that doesn't give us any problems, then most of the time that's our limit. So if we look at this first problem on the left here, we see this, we would read this the limit of x squared as x approaches 2. And we can say that would just equal 2 squared, and which is just 4. So very basic, we just plug in the x value, and if we don't get any issues going on, then we're usually fine to call that the limit. The same thing works for this middle one. It's even a little simpler. I need to plug in negative 4. I've got the limit of x as x approaches negative 4. Well, that's just negative 4, because when I plug in the value, that's what I get. No problems. Now, this third one here is actually a little more basic, but it confuses people sometimes because there's nowhere to plug that 2 in. So we say, well, what is the limit as x approaches 2 of the constant function 3? Well, the constant function 3 is always 3. It really doesn't matter what x we're approaching. The limit is just 3 because the function is always 3. Wouldn't matter if we were x was approaching 75 or negative 9 million. Doesn't really matter. The function is always 3, so the limit is always 3. So they start out very basic, but this substitution method still works when we have more complicated functions like this one. So here we're going to try to do the limit of x squared plus x plus 1 divided by x plus 1 as x approaches 1. And we just start by trying to plug in that 1. So we say 1 squared plus 1 divided by 1 plus 1. And we get in the numerator 4. Right? 1 plus, nope. I am sorry, I wrote down the wrong problem. So we don't get 4 there. We get 3 there, obviously. That's okay. And we get, in the denominator, 1 plus 1 is 2. So we get 3 over 2 for our final answer. If we could reduce that fraction, we would, but no reason to do anything else with it at this point because it's completely reduced. Now, that works just fine. We can plug the 1 in. Now, we would have a little issue arise if instead we took that same function and we tried to evaluate the limit as x approaches negative 1. Because notice that when we try to plug that in, we get 1 plus negative 1 plus 1 divided by negative 1 plus 1, which is going to give us 1 divided by 0. And that's what we call an indeterminate form. Substitution doesn't work for us in this case. And we'll come back to those problems later on. At this point, we can't evaluate that limit just by the substitution method. Okay. So let's look at one more where we can plug in that value. And in this case, we can see that it works with trig functions as well. So all I'm going to do is take this function and plug in pi for x. So that means I'm going to get the limit of x times cosine x as x approaches pi is just pi times the cosine of pi. And of course, I know that the cosine of pi is negative 1, so I'm going to plug that in, and pi times negative 1, we just normally write that as negative pi. So we see that as x gets closer and closer to pi, the function x times cosine x gets closer and closer to negative pi. And so you just have to remember that when we first see a limit, if possible, we just try plugging in the x value. As long as we don't get any problems, we're pretty much done with that limit.